So yesterday we learned about the slope-intercept form of a line. And remember that it is characterized by y equals mx plus b. Cheney, what does m represent? The slope. And what does b represent? The y-intercept, which is where the graph crosses the y-axis. That's what those two values tell us. So remember, you can tell by looking at an equation if you have a line by seeing if there's any powers. If there's no powers, that means it's a line. But just because it's a line doesn't mean it's in slope-intercept form. You must have y by itself on one side. So the first example says, write the equation of the line in the form y equals mx plus b with the given information below. The first one, you're given the slope and you're given the y-intercept. You're given those two things. So Olivia, what will the equation be? In y equals mx plus b form, what will the equation be? Like that? Is that right, Jan? Except you're missing the x. Got to have the x as well. Negative 3/5 x plus 7 would be the equation. Okay, so if we want to do the second one, write that in slope-intercept form. Do we know what m and b are right now? Declan, do we know those values? Can we look at the graph and state one of those values? What? What's the y-intercept? That's right. That's where the graph crosses the y-axis. So our b value is -1. And we can find the slope by counting. You must choose 2 points that you know for sure are on the graph. The y-intercept is one of them. That's the point 0, 1. And 2, 2 is also on the graph. So we can count the rise and the run. To go from the y-intercept, you're going to rise 1, 2, 3 units up, and you're going to run 2 units to the right. So that's our slope. Remember, slope is rise over run. So it'll be a 3 on top over the 2 on the bottom, and we can't forget about the x. So there is our equation. Trying to make the 1 come over, but it doesn't want to move. There we go. 3x minus 1. 3 over 2x minus 1. Now, question C says if the slope is 5 and the line passes through the point -1, 7. So this is not the y-intercept. It's a different point. We didn't see one like this yesterday. We saw how we could graph it before, but that's not what we're asked to do. If you wanted to graph this, you'd start with the point, and then you'd apply the slope. You'd rise 5, run 1, because 5 is 5 over 1. Then you'd rise another 5 and rise another 1. Or you could rise -5 and run -1. But that's to graph it. Here we want to write the equation. So here's how we do this. We know the slope is 5, so remember that is our m value, the number in front of x. What we don't know is what the y-intercept is. We can find it, though, algebraically. If the line passes through the point -1, 7, that point must satisfy the equation. When x is -1, y must equal 7. So we can plug those values in to the equation that we started to build, and now we can figure out what b is. 5 times -1 is -5. To get the b by itself, we would add 5 to both sides. Because it's a -5 on the right side, the opposite of subtracting 5 is adding 5. So we'll add 5 to both sides, and then we can say b is, 7 plus 5 is 12. So now we know what b, our y-intercept, is. That's the piece we were missing to write our equation. So it'll be y equals 5x plus 12. Now we have the equation. Question D, you're given the y-intercept and a point. So using slope-intercept form, the y-intercept is the b value. That's -7. We don't know what m the slope is, but we can find it algebraically by once again subbing in the point. Y is 3 when y is 4 when x is negative 3. The graph passes through the point negative 3, 4, so that point must satisfy the equation. When x is negative 3, y will equal 4. So I need to, solve for m. I would add the 7 to both sides to get rid of the minus 7 on the right. So that leaves me with, on the left side, 4 plus 7 is 11. That's on the left side. On the right side, we have negative 3m. Right? It's m times negative 3, negative 3m. And so now to get m by itself, we would divide both sides by negative 3. And we will leave it as a fraction because 11 over negative 3, which means that the fraction is negative. It doesn't matter where the negative is. It could be in the top. It could be in the bottom. It could be in front of the fraction. But if you convert that to a decimal, you'll get a repeating decimal. And so you don't want to use that because that means you're going to have to round it to write it down. And now it's no longer actually the correct slope. So this equation will be y equals, our slope is negative 11 over 3x. The y-intercept was minus 7, so there's the equation of that line. So for this next one, you're given 2 points on the line. We did an example, actually the last 2 examples. Question C, we had a point in the slope, so we saw how that was done. Question D, we had a point in the y-intercept, so we saw how that was done. This one, you're just given the slope. So the way we're going to start this one is by finding the slope formula, finding the slope first using the slope formula. So remember, if you're using the slope formula, you have to designate one of the points as 0.1, the other one as 0.2. This gives us our values of x1, y1, x2, and y2. So y2 minus y1, that will be 6 take away 4, over x2 minus x1 will be 2 take away negative 2. 6 minus 4 is 2, and on the bottom the minus minus becomes a plus positive. 2 plus 2 is positive 4. So that gives us a slope of 1/2. 2 over 4 reduces to 1/2. So that's our slope. So now this one becomes just like question C, where we had the slope and we had a point. The only difference is in this case we have 2 points, but I'm going to show you it doesn't matter which point we choose to find out what b, the y-intercept is, you're going to get the same value. But m, the slope, is 1/2. It's y equals mx plus b. So if we find b using the first point, which is negative 2, 4, y is 4 when x is negative 2. And we'll solve for b. 1/2 of negative 2 is negative 1. And then to get b by itself, you would add 1 to both sides, so we get b to be 5. And the equation would be y equals 1/2 x plus 5. So that was using the point negative 2, 4. But we could also use the second point, we could use the point 2, 6. So that means when x is 2, y is now 6. 1/2 of 2 is 1. And then to get b by itself here, you would subtract the 1 from both sides, and you get the same value for b. b still equals 5. So it doesn't matter which of the 2 points you choose here, you'll get the same b value, the same y-intercept. So you don't have to do it twice. You could definitely do it to check because you should get the same b value no matter which of the 2 points you use, as long as you do things correctly. So now we want to graph these lines. It says they're lines, all the equations have the x and y to the power 1. Is the first one in slope-intercept form? Liam. Is that in slope-intercept form? Why? Because you have y by itself. Yes. So what's the slope then? What's the slope, Brooklyn? That's right. It's the number in front of x. And b, the y-intercept, is -4. So if we want to graph that, and we've done this before, we start with the y, a point, which in this case the y-intercept, which is -4. And then you apply the slope. Remember, slope is rise over run. So you're going to rise 2 and run 3. I can rise 2 and run another 3. I can rise 2 again, but when I run 3, I'm actually going to have to kind of guess where that last point is because that's off the grid. But we could also rise -2 and run -3 because the negative divided by negative is still a positive. If you rise -2, that means going down 2. Running -3 means going to the left 3. It still lines up with the other points that we did. So we can be fairly confident that we've done things correctly because all those points line up. And remember that our lines always have arrows on the end because they go forever in both directions. So that second equation is a line because there's no exponents. Riley, is it in slope-intercept form? Why not? Right. The y is not by itself. So in this case, we have to do some work. We have to do some algebra to get y by itself. You need positive y by itself. So what I would likely do here is I would add 3y to both sides. Because what that does is it gets the positive y term by itself. So on the left, you'll have a 2x and a plus 6 left. On the right, you have positive 3y. But we still don't have y by itself. We have one more step we need to do, which is to divide all the terms by 3, because that's what's in front of y. So on the left, you'll have 2 over 3x plus 6 divided by 3 is 2 equals y. Or y equals 2 over 3x plus 2. Now it's in slope-intercept form. So Sal, what's the slope of this line? The one we're just working on now. We haven't graphed it yet. The slope is just 2/3. It's whatever's in front of x. And the y-intercept, b, is positive 2. So to graph it, that's where we start. We start with our y-intercept of positive 2, and then we apply the slope. Again, it's 2/3, so rise 2, run 3. We have room to rise 2 and run 3 one more time, but we can't do it any more times. However, we could also rise -2 and run -3. Go down 2 and to the left 3. Go down 2 and to the left 3. All those points line up with the first ones that we did. So we can be fairly confident that we've done things correctly. So we draw our line going through those points, and we put arrows on the end. These two lines have the same slope. That means they go at the same angle, because that's what slope tells you, what angle is the line going at. So these next ones, excuse me, are a little bit different because there's only one variable. And I think we've seen ones like this before. However, to graph it, get y by itself. By subtracting the 2 from both sides, you'll get y equals -2. What this tells you is that the values of x can change, but y cannot. If x is 0, y is -2. If x is 2, y doesn't change. It's still -2. If y is -3, doesn't matter. Y is still -2. That's the equation. No matter what x is, and it can change, y doesn't. It's always -2. So this will be a line that is a horizontal line. And we always put arrows on the end. Whereas question D says that x equals 5. This means that the y values can change, but x doesn't. X is always 5. When y is 0, x is 5. When y is 3, x is still 5. When y is 5, x is also 5. When y is -2, x is still 5. The values of y can change, but x won't. It's always 5. So there's that line. And again, we put arrows on the end because a line always goes in the same direction forever. That's what a line is. It has a constant slope. So question A here says, what are the slope and y-intercepts of the line shown in the graph? What do you think, Chloe? What can we say? Do we know either the slope or y-intercept just by looking at the graph? Aha. Do we know the slope or y-intercept just by looking at the graph? Take your other earbud out as well. You should be more like Brooklyn back there. See how she's just paying attention? Doesn't have her earbuds in. Do we know the slope or y-intercept of this graph? What do we know? We do? Okay, what are they then? Y-intercept is what, sorry? +1. So you're saying the slope is 2/3? Is that right, Princess? Why not? Yeah, the slope is definitely negative because as you go left to right, the line is falling. But to make sure, let's choose 2 points. So the point -3, 3 is on there, and 0, 1. So if you go from the first point to the second point, you will rise -2, and you will run 3. But again, it's negative. There should be a negative there. So if we want to write the equation in y equals mx plus b, what will the equation look like, Brooklyn? Pardon? Okay, didn't hear you. Sorry. Ava, can you help her? What will the equation look like? Like that? Gotta have the x. Because m is the slope and b is the y-intercept. That's what y equals mx plus b tells us. Now then it says use graphing technology to check your equation. So if you go to y equals in your calculator, you clear any equations that are in there already. And you input. Now, m, the slope is -2/3. So to put that in there, I'm going to open a bracket, and I'm going to go -2 divided by 3, close the bracket. There's our slope. Then the x key is in that second row from the top, second column. right below the mode, and then plus 1. Now, my windows are probably set to something different because I was using it this morning in another class. Yep. So what I'm going to do is I'm going to go zoom 6. Zoom key is at the very top there in the middle, and then 6 sets the windows to the standard settings, which is between -10 and +10 on both axes. So that certainly looks like the line that we have, okay? But we can check it, and here's how. First off, we know that this line has a y-intercept of +1. So if I go into the trace mode, which is the second key on the very top, second last key, I should say, on that very top row. If I go into trace, normally your calculator automatically defaults to where x is 0. And you see on the bottom it says x is 0 and y equals 1. Well, that's the right y-intercept, +1. We also said that the point -3, 3 was on this line. Put your phone away. So when you're in the trace mode like we are, and we know we are because we see the x and y values displayed at the bottom, you can manually input any x value you want. To check this point here, the x value again is -3. So if I go negative, and notice what happens, as soon as I hit negative, the bottom changes. It says x equals, and the negative that I put in there, and then I put 3, and then I go enter, and it goes to that point on the graph, and it also tells us what the y value is. That is the right y value. Let's check one more point. For example, it appears that the point 3, -1 is on this graph on the page. So if we check that point as well by, again, I'm in the trace mode because the x and y values are displayed at the bottom. So if I just go 3, enter, it'll go to that point. It'll tell us the y value of -1. So we've just checked 3 points from our equation, which we put in our calculator, and they all match those same 3 points on the graph on the page. That tells us that our equation is correct. That's what that tells us. The equation that we came up with is correct. So we'll do the same thing for this one, Jan. This line has a positive slope. As you go left to right, the line is rising. So we know that our slope has to be positive. We want to write the equation in y equals mx plus b. So to do that, we need to know the slope and the y-intercept. Do we know either of those, Keen? Just by looking at the graph, do we know either the slope or the y-intercept? Princess? Do we know the slope or the y-intercept by looking at the graph? What do we know? And why do you say that? It's because that's where it crosses the y-axis. That's what the y-intercept tells you. And which parameter is that in the equation? Is it the y, the m, the x, or the b? It's the b. It's not the y, it's b. B tells you the y-intercept. The y-intercept is b. So our b value is -1 for this equation. To find the slope, we'll count the rise and the run from one point to another. So looking at this, I'm going to start from my y-intercept, and I'm going to go to the point 4, 2. Because that's an exact point. You couldn't use this point here because you don't know exactly what it is. You couldn't use that point there because you don't know exactly what it is. You have to know both the x and the y values. It has to be an actual point that you can count to get to. So to get from that bottom point to the top point, you're going to rise up and you're going to run to the right. You're going to rise up 1, 2, 3, and you're going to run to the right 4. Slope is rise over run. You're rising up 3 and to the right 4. Those are both positive directions. So our slope is 3/4. Which parameter is that in our equation, Riley? Where does the 3/4 go in our equation? What do we replace the 3/4? Or what part of the equation do we replace with 3/4? That's right. M is the slope. So what will our equation be? Emil? What will our equation look like? Y equals what? Three over 4x minus 1. There's our equation. And again, you can check that on the calculator. So if you go to y equals, clear the equation out of there. In brackets, I'll go 3 over 4 x minus 1. Now in this case, because 3/4 is exactly 0.75, you could have put 0.75 in front of the x as well. But the previous one, that wouldn't work that way because the slope was negative 2/3, and 2/3 is 0.6 repeating. You'd have to round it off at some point. It's no longer exact then, and it would throw off your graph. But in this case, the slope is a terminating decimal, so we could have put 0.75 in. So when you hit graph, it certainly looks like the graph on the right, but to confirm that, if we go trace, again, it defaults to the y-intercept where x is 0, y is negative 1, that's correct. We use this 0.4, 2 over here to find the slope. So if I let x equal 4, hit enter, I get the right y value of positive 2. I can check one more point if I want, say this point down there, which is the point negative 4, negative 4. So in the trace mode, if I let x equal negative 4, I get the right y value of negative 4 as well. So we just showed that our equation that we put in our calculator and graphed it matches the graph on the page. Our equation is correct. So you can always check these. Okay. So page 17 and 18, yes, for marks, because Keen asked. So rip that out, make sure your name's on it. You're going to hand it in. Brooklyn, you didn't hand in your quiz yesterday. You didn't hand it in yesterday. Look in your binder.